Hello friends and welcome to a lecture on Operation Research. This is Professor Arvind Prasad. Today we will learn how to solve an assignment problem. Let's first understand what is an assignment problem. In an assignment problem, there are jobs and they need to be assigned to facilities. The point to be noted here is that one job can be only assigned to one facility. Jobs and facilities are not divisible. That is, I cannot split a job and give it to two facilities. And also there is a cost associated with each and every assignment. That is, whenever a job is assigned to any facility, a facility is a place where the job will be processed, it will be completed. So there's a cost associated to it. The idea here in most of the cases is to minimize the cost, because there would be n jobs and there would be n facilities, equal number of facilities to process them, because as we know that jobs and facilities are not divisible. So there is going to be a cost associated with this entire operation of giving jobs to facilities. Now this cost needs to be minimized off. Now on this table, what we have is, in the rows we have the jobs and in the column we have the facilities. Okay. Now in the column number 1 is facility number 1, column number 2 represents the facility number 2, and in the rows the row number 1 is associated with job number 1, and so on. Now if job 1 is assigned to facility 1, the cost associated to that would be C11. Supposing job number 1 is assigned to facility number 2, the cost associated to that would be C12. And if it is assigned to any facility N, the cost would be C1N. Now all the entries of C have the same meaning and the same understanding. That is, if we assign job number N to facility number N, the cost associated to that would be CNN. Now jobs here have a supply as 1 and the demand in the facilities is also 1, because only one job can be given to one facility. Okay. Now the mathematical representation would be, first what we have to do is, the idea here would be, if Z is the effectiveness function, then Cij, Xij, the summation of that, we have to minimize this. That is, the cost multiplied by the assignment and the summation of all such assignments, that is the summation of the cost and the assignments, that needs to be minimized off. Now Xij can have only two values, that is 0 and 1. 0 means a particular job has not been assigned to a particular facility. Because if we have job number 1, it cannot be given to all n facilities, it has to be given to a particular facility. It would be a jth facility, right? So it can be for all other indices of j, it would be 0. Now we also know that summation I is equal to 1 to n, Xij is going to be 1. That is because in each row we are going to have only one job. And summation j is equal to 1 to n, Xij is also going to be 1, because each and every facility is going to get only one job. Now let's take up a problem. What we have is in a machine tool company. So a machine tool company decides to make 4 sub-assemblies through 4 contractors. Each contractor is to receive only one sub-assembly. The cost of each sub-assembly is determined by the bids submitted by each contractors. Now this is shown in the table in the next slide. I'll just show it in a minute. And the cost is in 100 rupees. Now assign different sub-assemblies to different contractors so as to minimize the total cost. So here we go. We have sub-assemblies 1, 2, 3, 4 in the rows and contractors 1, 2, 3, 4 in the columns. Now, if we give job or sub-assembly number 1 to contractor number 1 so that it can be made, the cost is going to be 1500 rupees. Let's say if we take sub-assembly number 3 and give it to contractor number 2, the cost is going to be 1200 rupees. So how do we do an allocation of these sub-assemblies to contractors so that the cost is minimum? For that, we use the Hungarian method. Now, how do we use the Hungarian method? What is it? First is you need to check that you have n jobs, and that is, you can call them sources also, and n destinations, that is places where they can be processed. Okay, each job needs to be processed. So n destination, or a destination would be a place where it could be processed. So destination may be a factory where it can be processed, or destination may be a machine where it can be processed. But the essential part here is you have to have the machines to process the jobs equal to the number of jobs, because only one job can be given only to one machine, or one job can be only given to one contractor or one factory to be made. Now, second part is to reduce the matrix. We are going to have a cost matrix. Now, how do we reduce this cost matrix? First, we take every row, we study every row, and we check the least entry in that row. And the least entry now is subtracted from all the higher entries. Once that is done, we check each and every row that we have done this, and we check each and every column. Now, each column should have at least 1 0. Now, in case each column does not have any 1 0, then we take the columns which do not have 0 and we check what is the least entry in that, and then we subtract that from the higher ones. Of course, in both these steps, that is in the row step and the column step, we subtract the entry by itself also. So that leads to a 0. Let's have a look what we have done here. Now, the least entry in row number 1 was in column number 2. So let's have a look at the problem. Yes. So the least entry, let us say in row number 1, was in column number 2, that is 13. Now this 13, we subtract 13 from 13. So this is 0. And then also what we do is we subtract 13 from 15. So that's going to give us 2. Similarly, we are going to subtract 13 from 14 and 13 from 17. So that's going to give us 1 and 4. So let's go ahead and have a look. Yes. So we have 2, we have 0, we have 1, and we have 4. Now let's take row number 2. In row number 2, the least entry is 11. Now this 11 we subtract from itself and all other entries, higher entries. So we are going to subtract 11 from 12. We are going to subtract 11 from 15, and we are going to subtract 11 from 13. So we will get 1. Oops. We are going to get 1, 4, and 2. So there we are. We have 1, 4, and 2. Similarly, the same thing is done for row number 3 and row number 4. Now let's observe the columns. In column number 1, we have 1, 0. In column number 2 also, we have 1, 0. In column number 1, it is in cell 2, 1. In column number 2, it has cell 1, 2. In column number 3, it is in cell 3, 3. Now, observe here. In column number 4, we don't have any 0. Now, what do we do here? We take the least entry here, which is 1, and subtract it from all other entries in the same column. So, we subtract 1 from 2, which is above, 1 from 2, which is below, and 1 from 4, which is first in the column. So, we get 2, we get 3, 1, 0, 1. So, this is the column we get. The resulting column now is this. Now, once again, we check. We have 0 in column number 1, 0 in column number 2, 0 in column number 3, and 0 in column number 4. Now, what do? First, we go by the first row and we check all the rows going down, and we check which row has only one single 0. Remember, we have to start from the first row. The first row may or may not have one single 0. So we have to start with the first row, go down and look which row is the first one which has 1, 0. Now in this case, it happens to be row number 1 itself. So what we do is we mark it. We put a square box to it. Right. Now, again, we look. Okay. So where do we have one single 0? We have it here. And we have marked it. Now here comes the other part. Yes, single 0. We have marked it. Now observe row number 3. It has 2 zeros. And what we have done is we have marked the 0 in the 4th row. Once we have marked the 0 in the 4th row, we have to check that whether in the same column, 4th row, column number 3, do we have any 0. Now this we have to do for all the rows. Let us say, again, let's start with row number 1. In row number 1, the 0 is in column number 2. We have to check in column number 2 whether any 0 is there or not. If it's not there, go to the next row. Next row, we check if there is a single 0 entry. If there is a single 0 entry, we mark it with a square. And we check in the column. In this case, it's going to be column number 1, if there is any 0 entry or not. Now, coming to row number 4, we mark the 0 because there's single 0 here. And when we check the column, that is column number 3, we find there is one more 0. Right? So what we do is we cross out this 0. Okay. Now afterwards, if we have crossed out this 0 from row number 3, we have only one 0 left. Now we mark it with a square. Looking at this table, how many lines can we draw which would cover all the zeros? Well, we can draw a line across row number 1. We can draw a line across row number 2. We can draw a line across row number 4. And we can draw a line across column number 4. Right. So we have 4 lines which go through all the zeros. And this is equal to also the dimension of the row or the column. So if the number of lines which goes through all zeros is equal to the dimension of the row or column, and the dimension of the row or column in this case, that is the assignment problem, is going to be the same. It's going to be the same. Okay, so here we have 4 lines and we have 4 rows. So therefore, this is an feasible and optimized solution. And we have now arrived at the optimized solution for this assignment problem. Now, what's going to be the cost? The cost is going to be, the first assignment was in row 1, column 2. So let's check it now. So row 1, column 2, it's going to be 13. The second assignment is in row 2, column 1. So that's going to be 11. So it's 13 plus 11. Similarly, it's going to be row 3, column 4. That's going to be 11. And finally, it's going to be row 4 and column 3. That's going to be 14. So the total cost is going to be 13 into 1 plus 11 into 1 plus 11 into 1 plus 14 into 1. That is rupees 4,900. Now this is the optimized cost for assigning 4 jobs to 4 contractors or 4 sub-assemblies to 4 contractors using the Hungarian method. So if you like this video, give it a thumbs up. Also press the bell icon and subscribe my channel. And if you also like this video, share it with your other friends who would be interested in learning from this. Goodbye friends. Have a great time and keep watching. Such short videos for quickly learning operation research methods will be posted in this playlist. Keep watching. Goodbye. Have a great time.